Hello everyone. Today in first class solution, we're providing solutions to some misconceptions that students usually encounter in their bid to solve problems in mathematics. In my years of experience in teaching mathematics, I observed that there are some common errors that students usually make in their bid to solve problems on fractions. In doing this, look at this first fraction, for instance. I will solve the question and at the same time point out those errors so as to correct them, especially for the benefit of our students that are preparing for external examinations like the WAEC, NECO, and JAM. Let's take a look at this first one, for instance. I gave a student this question and the student did something like this. He said, okay, we have 2xy plus 4y over 2x over 2x. Do you know what the student did? The student decided to just cancel 2x and 2x and said the answer is what? Y plus 4y. It didn't shock me. Oh. You know why it didn't shock me? It's expected that the student also know that in this expression we have as the numerator, except if you have here to be multiplication, except here happens to multiplication, that is where you now cancel 2x to be with 2x and have y times 4y, which might even give you 4y squared. But since here is addition, what do we do? Let me show you. Since we have addition there, we just have 2xy plus 4y over 2x. With this addition, we just look at what is common. That is the highest common factor between 2xy and what? And 4y. And if you look carefully, we have 2 is common here and here, and at the same time, y is common here and here. So we have 2y as the highest common factor. Then the rest will be in the brackets, where we have, after taking 2y, x is left. We have x, you bring your plus 4y divided by 2y. Y cancels y. 4 divided by 2, you have what? 2. All over what? 2x. Now looking at this again, remember I told you that supposing we have multiplication here, this 2x, you will have cancelled this 2x. Now look at, we now have this bracket represent multiplication. The brackets here represent multiplication. So here, something can still cancel because of this multiplication. Something can still cancel. 2 can cancel 2. If we had x here, x will have cancelled x and our answer will just simply be x plus 2. But because here is y and here is x, they cannot cancel themselves. They are not the same. So our final answer becomes what? Y into x plus 2. Y into x plus 2 all over what? All over x. That is the answer for this first one. In the same vein also, let's take a look at the solution for the second one. The second one, we have Cp minus t squared all over what? P minus t all what? Squared. I gave a student this one. Do you know what the student did? It will shock you what the student did. The student decided to just cancel. He said, okay, since here is power, here is power. Power cancels power. Look at what the student did again. He said, P minus T, cancel P minus T. And the answer is what? T. I almost fainted. But why I did not faint? Because there's still room to correct that student going forward. So what I just did was that I said, no, come back, let me teach you. I said, look at this. We have T minus, we have TP minus T squared all over P minus T, all brackets what? Squared. Now look at this. Look at the numerator here. From this numerator, you discover that T is common. True or false? Yes, T is common. We have our T to be common. Then the rest, if you take T from here, you have P left. That is Tp divided by T, you have P left. Put your minus. This T is like T times T. That is T times itself 2 times. So when you take one of the T, and the other T will be what? Will be left. So having taken T to be common, the rest left will be what? T. All over. Another issue now comes in. Look at this bracket. Just like this T squared, we are having this P minus T. That is, this square is affecting the P minus T. What you just need to just do is to multiply P minus T by itself. So you just have it twice, P minus T bracket what? P minus c. This is now when p minus c will cancel p minus c, because this is timesing this and this is timesing this. Because of that times, you now have to what? Cancel. So we have p minus c cancels p minus c, and our final answer there becomes what? C all over what? P minus c. As simple as it sounds, right? All right, let us solve this one. Let us solve this last one. I want to explain something here for the benefit of our students. Let us solve this and see how it is. Where will I rub off? Let me do this. Let me do this. Now for the last one, we have C. I gave a student this question. Look at what the student did. 2k plus 2h over k squared minus h squared. All right, look at what the student did. The student said 2 h cancel h and k cancel k. Then have 2 plus 2 over what? Remember yes, it was k squared, and you have 1k left, minus h squared, you have 1k, 1h left. Then you now have its final answer as 4 over what? K plus h. You know, I almost off, but the offing was not, was short-lived because there was room for corrections. I said, okay, come, let me teach you so as to maintain a relative permanent change in you. I said, okay, bring it, come, let me explain better. I said, look at this equation. I asked the student, have we heard of something like difference of two squares? He said yes. So okay, let us apply it here. Look at this 2k plus 2h plus 2h over k squared minus h squared. K squared minus h squared. What you just need to do is the same thing. Looking at this numerator, start from the numerator. Look at this numerator. There must be common factor between the values on the numerator. We have 2k plus 2h. It means that 2 is common. So you have 2 into what? The remainder, k plus what? Plus h. All over. Look at this. Difference of 2 square. In difference of 2 square, we were told that if you have, for instance, a minus b, a square minus b square, that the answer is equal to a minus b multiplied by a plus b. That is the answer. A square minus b square, the answer will be a minus b multiplied by a plus b. One will be minus, one will be plus. The same vein, b square plus c square is the same difference of 2 square. It will give us b plus c into what? B minus c. With this logic here, this k square minus h square is difference of 2 square. So I haven't solved the numerator to be this. The denominator will now be k minus h into what? K plus h. As simple as that. Where we have k plus h and k plus h being similar, meaning that they can now strike out themselves, and our final answer will now be 2 over what? K minus h. Thank you very much for watching to this point, and do well to ensure that you teach your students this and also share this video to them so that they will be able to learn some of these mistakes and avoid them going forward. God bless you.